three planets during the same journey through the solar system unless it adhered to this plane of the ecliptic, passing through the solar system within 5 degrees of the ecliptic. And as you can see, that's a highly unlikely event, and we're just getting started. As I showed in a recent paper, the brightness of 3I Atlas implies an object that is approximately 20 kilometers in diameter for a typical albedo of approximately 5%, too large for an interstellar asteroid. We should have detected a million objects below the 100-meter scale of the first reported interstellar object, Oumuamua, for each 20-kilometer object. Number three, no spectral features of cometary gas are found in spectroscopic observations of 3I Atlas. The detected reddening of reflected sunlight could originate from the surface of the object. The so-called coma observed around 3I Atlas is inconclusive given the motion of the object and the inevitable smearing of its image over the exposure time. Number four, for its orbital parameters, 3I Atlas is synchronized to approach unusually close to Venus, 0.65 astronomical units, Mars, 0.19 astronomical units, and Jupiter, 0.36 astronomical units, with a cumulative probability of 0.005% relative to orbits with the same orbital parameters but a random arrival time. And by the way, those are the same odds that Grok puts forward. Let's go ahead and continue. 3I Atlas achieves perihelion on the opposite side of the sun relative to Earth. This could be intentional to avoid detailed observations from Earth-based telescopes when the object is brightest or when gadgets are sent to Earth from that hidden vantage point. The retrograde trajectory at a perihelion speed of 68 kilometers per second, opposite to the direction of the motion of the Earth around the sun at 30 kilometers per second, makes the velocity difference between the Earth and 3I Atlas 98 kilometers per second. It is therefore impractical for Earthlings to intercept or land on 3I Atlas at closest approach by boarding chemical rockets, since our best rockets reach at most a third of that speed. Number six, the optimal point for a reverse solar Oberth maneuver to become bound to the sun is at perihelion, in other words, the closest approach to the sun. In an Oberth maneuver, the thrust of a spacecraft is applied at its maximum orbital speed so as to maximize the resulting change in kinetic energy. This applies both to accelerating to achieve solar system escape or alternatively to slow down from a high speed, also called reverse Oberth maneuver, in order to break, stay bound to the sun, and potentially visit a planet like Earth. It is this optimal breaking point for 3I Atlas that is obscured from our view by the sun. What are the odds of that? The optimal point for 3I Atlas to change course and perhaps intercept our planet is at a point where we won't be able to see it. And by the way, as 3I Atlas approaches our planet, assuming that happens, it will be lost in the sun's glare for the vast majority of its approach until it's virtually on top of us. Number seven, the direction from where 3I Atlas is coming is oriented towards the bright Milky Way center, where crowding by background stars made its detection difficult prior to July of 2025. If astronomers were to detect 3I Atlas more than a year earlier, then we could have had an opportunity to launch a spacecraft that could have intercepted it along its path. By now, such an interception is not feasible with chemical rockets. Is it possible the 3I Atlas is coming